we are going to draw 3 non-identical triangles so that 2 angles measure 50 and 60 degrees and one side is 5 centimeters. So I'm going to start with a 5 centimeter long line, and then I'm going to make one of these angles be a 50-degree angle by putting my point at 50, and then the other angle as a 60-degree angle, and both of these are acute, so we want the side that's going to make them the small ones. Then using my ruler, I'm going to connect the ends of my segments with those marks that I created. So we'll slide this over here, and then we're going to connect and draw a line through those marks. And then I need to do the other side as well. So then align that with the end point and the mark that you made and draw your line through those. And you'll notice that it crosses, creating a triangle. So we have our 5 centimeter here, we have our 50-degree angle here, and our 60-degree angle here. So we've met those 3 criteria. I'm just going to clean it up a little bit, but that's not required. Now we're going to do the same thing, but instead we are going to maybe put the 60 on the other side. So we'll start again by drawing a 5 centimeter long line segment. And this time, instead of putting the 50 on the left, I'm going to put the 60-degree angle on the left. And then I'm going to connect the point with my end point. In a triangle, all of the angles have to add up to 180. So I need to figure out what that missing piece is. If I subtract 50 and I subtract 60, how much does it leave me with for this third angle? And it actually is going to leave me with 70. So then I'm going to make the other side be 70 degrees. And again, we're using the acute 70-degree mark. And we will line it up. If this one is 70, then using our angle sum of a triangle, 60 plus 70, to get to 180, that leaves us with 50. Does that triangle look identical to the other triangle? So just by changing where the 50-degree angle is, we have made a triangle that is not identical to the first triangle. So the placement of the 5 centimeters and the 2 angles changes what the triangle is going to look like. And now I'm going to do one more, because it says to create 3 non-identical triangles. Again, draw your 5 centimeter line, and then this time we're going to do 50 and 70 as our angles. We want the one that's going to create the acute angle. There is a 50 over here, and there's also a 50 over here. So we want to make sure that we're using the one that's going to make the angle small, which is the one that's on the right side. So we definitely want this 50 over here. And then we're going to make the other one 70. And again, we want the 70 that's going to make it small, and that one's lined up with the 110. Draw a line connecting your end points with your marks, and then do the same thing for the other side. And let's make sure we label all of our different pieces. This one was 5 centimeters. This one was 50 degrees. This one is 70 degrees. So this one must be our 60-degree angle. And again, it looks different than the other two. It's a little bit taller than the first one and a little shorter than the second one. So all three are not identical. Then part B says, based on the diagram you drew for part A, what can you generalize about the criteria of three given angles in a triangle? Does the criteria determine a unique triangle? Meaning, if you were given this information, are you guaranteed to make identical triangles? Or can you make triangles that are not identical? Unique means they're all going to be the same. It's creating one unique triangle every single time. They're always going to be the same unique single triangle. So, no. It is possible to draw triangles that are not identical. Even if they all have the same three angles. In this problem, they all have 150, 160, and 170-degree angle, but they don't all come out identical. Just because the numbers are the same, we don't get the same triangles every time. So we didn't get a unique triangle, we got three non-identical triangles. And in problem 2, they all had, I think, 60-degree angles, because they were equilaterals, but they were all different sizes. So even though those angles were the same, the triangles were not identical.